everybody, welcome to another math video. For this one, I'll be going over systems of equations. Okay, so there's three ways we're going to use to solve these, and I'll go over all three of them. I hope this video isn't going to be too long because of that, but let's just go ahead and get started. So first is the addition method. And first thing you're going to want to do is make sure the equations look the same or similar, where you got all your variables on one side and all your constants on the opposite side of the equal sign. Then you want to choose a variable to cancel out, and if they have the same signs in each equation for the variable you want to cancel out, then you need to make sure you multiply one equation by a negative value. If they have different coefficients, especially, you have to multiply by a factor to get to the least common multiple. Then you want to add the equations together, which will cancel out the variable you selected, and solve for whatever's left. Then you take whatever that variable you solve for, put it into one of the original two equations, and solve for whatever is left, and that's your solution. So here's the thing: if the variables cancel out, but the statement is true, then you have infinite solutions. But if the variables cancel out and the statement is false, then you have no solution. So to get an idea of what this looks like, we'll go through an example. Okay? So we're going to find the solution to these two equations, 2x plus y equals 8, and 4x minus y equals 4. Okay, so I'm going to line them up first. So you can see here, the y's have the same coefficients with opposite signs. So I can right off the bat add these equations together, because what happens is the y's will cancel out. So you just do normal addition straight down. Okay, so 2x and 4x will give me 6x. 8 plus 4 will give me 12. And then from here you just solve for x. I'm going to divide both sides by 6. And that gives me 2 for x. Now I'm going to substitute this into one of the first two equations. So let's say I wanted to use the first equation. Okay, so I'll substitute into x there. I'll simplify that, and then solve for y. Okay, and now what if I wanted to use the second equation? Well, we'll do the same thing. Substitute into x, simplify that, isolate the variable, and solve. So in this case, I'm going to divide by -1 to both sides of the equation. Gives me that. So it doesn't matter which equation you end up using, you should get the same answer no matter what. So in this case, our solution is the ordered pair 2, 4. So I hope that one was pretty straightforward. Pretty simple when the variable you want to cancel out already has opposite signs with the same coefficient. Okay, now let's take a look at this one. 2x plus y equals 8, 3x plus 2y equals 4. So you see here, none of my variables have opposite signs, and they all have different coefficients. So in this case, let's say I wanted to cancel out y again. So I'm going to have to find an LCM, that is a least common multiple. So the first equation, y, has a coefficient of 1, and the second equation, 2y, has a coefficient of 2. So least common multiple is 2. So I'm going to have to multiply one of these by a negative. So since this already has a positive 2, I'll probably multiply this equation here, by a -2, just to keep things simple. Okay, so the second equation stays the same, doesn't change, because we didn't multiply anything to it. Okay, so from here, just add. Okay, because the two y's will cancel out, they have opposite signs. -4x plus 3x will give me an opposite of x, or -1x. -16 plus 4 will give me a -12, and if I divide both sides by -1, that's what I get for x. Then I'll substitute again into one of the first two equations, or, doesn't matter which one you use, you should get the same answer no matter what, as long as your signs are correct, your steps are correct. So that's our solution here. Okay, now what if you wanted to cancel the x's instead? So let's try that. So same equations, but this time we're going to cancel out the x variables. So this time we're looking at these two terms here, and we're going to have to find a lowest common multiple for 2 and 3, which in this case is 6. So I'm going to do that. So this equation, I'll have to multiply everything by 3. This equation, I have to multiply everything by 2. But in order for the x's to cancel out, remember they have to have opposite signs. So I'm going to have to multiply one of the equations by a negative. So I multiply the second equation by negative 2. And one thing I forgot to mention earlier was that when you multiply something to one thing, you actually have to multiply it to everything in that whole thing. So like I was saying here, I have to multiply 3 to the 2x to get to 6x. But I can't just multiply 3 to 2x and be done with it. I have to multiply 3 to each term. Same with this equation. I have to multiply negative 2 to each term. Okay? So again, here we're going to add straight up and down. The 6x's will cancel out because they have opposite signs. 3y minus 4y gives me a negative 1y. 24 minus 8 gives me 16. And if I solve for y by dividing by negative 1 to both sides, I get that. And again, I'm going to substitute that into either equation, doesn't matter which one I substitute into. I should get the same answer no matter what. So again, you can see we get the same answer. Okay, so it doesn't matter which variable you ultimately choose to cancel out. If you do all your steps correctly, everything should come out the same. Alright, so I just did the same problem for you 2 ways, canceling out the x's and canceling out the y's. You can see we got the same answer both times. Okay, so let's move on to our next method, the substitution method. So if for one of your equations, if it hasn't already been done so, you want to solve for one of the 2 variables there. Then you want to substitute that into the other equation for whatever variable you solved. Finish solving up for that variable, then again substitute that value into one of the original 2 equations, and then solve for whatever's left. And again, you got these 2 parts here. If it'll make a lot more sense when you do these problems. So if all the variables cancel out and the statement is true, so you get something like 1 equal to 1, something like that, where a number on one side is the same number on the opposite side of the equal sign, you got infinite solutions. But if you get a situation like this, where you have all the variables cancel out, and you have a value on one side of the equal sign that's with a different value on the opposite side of the equal sign, then you have no solution because that's a false statement. So you get something like 2 equals negative 1. Right? That's not true. But let's get into the substitution method here. So we're gonna find the solution to x minus 3y equals 2 and y equals x plus 2. So in this case, this equation has already been solved for y. So I'm going to substitute x plus 2 into this equation here wherever I see y. So I'll start with that. Y is also equal to this. So I'm going to put that in, I'm going to substitute that in for y. Then I'm going to distribute, because this is multiplication here. Combine like terms, because I got x's on one side of the equal sign here that I can combine. Isolate the variable, and then solve for x. Okay, and then again we can substitute this into one of the first original equations. So you can do it the easy way by doing this one, which is already solved for y. Or if you want, you can always do this one too. Substitute into x, solve for y. Okay, you should still get the same answer either way. So that's our solution there. Okay, now moving on to the graphing method. So the easiest way to do this is to set each equation into slope-intercept form and then graph them using the equation. So if the lines intersect, then you have one or two solutions, depending on what your equations look like. You might be doing a quadratic equation with a linear equation, so it might intersect it more than once. If you're doing linear stuff, then if the lines overlap, you have infinite solutions, and if they don't intersect or overlap, then there's no solution. Okay, so let's take a look at a couple of examples here. So we're going to find the solution to these two equations here. 4x plus 2y equals 8. 2x plus y equals negative 2. So first step was to put these into slope-intercept form, because we're going to graph these. Okay, so basically we're solving for y. Okay, so there's that equation there. Then we'll do the other one. Same thing, we'll solve for y. Okay, so if you remember how to graph this, great. If not, check out my slope-intercept video for a quick refresher. But the lines should end up looking like this, so you can see they don't overlap and they don't intersect, which means for these two equations there is no solution. Okay, so sometimes having the picture makes it easier to see that, hey, I got no solution in this case, or I only got one solution, or I got infinite solutions. So let's take a look at another example. Right? No solution there. Okay, so now we're going to find the solution to 5x minus 2y equals 2, and negative 10x plus 4y equals negative 4. So we're going to start off the same. We're going to put these into slope-intercept form, so we're solving for y. Okay, now we'll do the second equation. Okay, so reduce, always want to reduce, and we'll graph. Okay, so there's our graph there. So it just turns out that both lines are the same equation, which means in this case, for these two equations, we have infinite solutions. Okay, so in this case, both lines overlapped each other. Okay, so we went through 3 different methods of solving systems of equations. I apologize for this video being so long, but it's important to see the steps, especially if you're doing the addition method. Alright guys, well that's it for this video. Thanks for tuning in, and I'll catch you next time.